All right, so here we go. Here is a box plot example, or also known as a box and whisker plot. This is by far my favorite graphical representation of data. So if we just have a long string of data here, sure, we can find the average, we can find the median, we can find the mode, we could make a histogram, but box plot really is great for showing how spread out data is or how clustered it is. And I'm going to show you that with a couple examples at the end of the video. So first off, how do I just create a box plot? And the very first thing you need to do is you need to take your data set. Our data set was student responses for how far they could jump. So each number represents a student's jump distance in inches. So 108, that is incredible. That's over 8 feet. And 4 inches, my guess is that's probably someone that meant to put 4 feet. But sure, 4-inch jump. That's I think probably could do a little better than that, but maybe it wasn't their best day. All right. So very first thing you need to do in making a box plot is you need to organize the data from least to greatest. So I went ahead and did this already. So I put it from least to greatest. The reason for needing to do that is one of the things that you must do. These are the things that you need for a box plot. You need to know the minimum, you need to know the maximum, and you need to know the median. All of those things really are helpful for lining it up from least to greatest. These quartiles, you also need it from least to greatest. All right, so we've got the data from least to greatest, and now we can start filling in our table for the 5 key pieces of information we need to make this box plot. So we need the minimum score or the minimum value, and the lowest score, the lowest jump distance was 4. And then we know the highest is 108. All right, so nobody jumped further than 108, so 100% of the people jumped 108 or less, and 100% of the people jumped 4 or more, right? Nobody else outside of those range. We need to find the median now, which is the member or the number that breaks the data exactly in half. So count the numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if it's an even number, there's not going to be a middle member. It's going to be split exactly in half. So I'm going to take red to represent my low 50%, and then I'm going to do green for representing the upper 50%. So I'll make a little bracket and bracket the bottom 10, the lowest, the least far. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so from 4 to 51, those are the lower half, lower 50%. And then here from 108, and just count to make sure: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This from 57 inches to 108 inches, this is the upper 50%. All right. So I need to know, well, what number, this median, what median splits this exactly in half? What splits the data in half? And to find that, we need to find the average of those two numbers. So I need to find the average of 51 and 56. To do that, we add them together. And then we divide it by 2 because there's 2 numbers there. So 51 plus 57 is 108. And half of 108, or 108 divided by 2, is 54. All right, that's a very special number. That's the median. So half of the data, half of the students jumped less than 54 inches. Half of the students jumped more than 54 inches. So I'm going to put that in our table. So we got 54. Now we just need the quartiles, the lower quarter and the upper quarter mark. So that's the half mark. Well, quarters would just be what splits the data, what splits it into quarters. All right, that looks to be about there, but let's make sure. So let's take our lower let's take our lower half, and some people like to rewrite it, so let's go ahead and do that. So we're going to rewrite the lower half, and we're going to find the median here. So 4, 12, 13, 24, 27, 36, 40, 46, 48, and 51. So 51 is included in the lower half. All right, and let's find the median there. So let's find the median, the middle of the middle. So we're looking for, it's probably right here, just from the way it looks. So let's go and let's say, okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, an even number. So there's going to be 5 low and 5 high. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So this is the median of the lower 50%. So this does become Q1. That's our first quartile. So to find that, we do 27 plus 36, and then divide it by 2, and then divide it by 2. So 27 plus 36 is 60, what is that, 63. And 63 divided by 2 is 31 and a half. So 31 and a half is our lower quartile. So what does that mean? It means that 25% of our data, our students jumped lower than that. And then 25% of our students are in this range between 31 and a half and 54 inches. So it's breaking it up into equal portions of students. And now let's get the upper half. So let's redraw. And for the upper half, we have 57, 58, 60, 66, 72, 72, 86, 96, 103, 108. All right, if there were 10 lows, that means there's 10 highs. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So our median is right here, or our median of the median. So this is our upper quartile, Upper quartile. Quarter, fourth. So our upper fourth, right? This splits it into the upper fourth here. What number does that? And that is, well, 72 plus 72 divided by 2. And, well, you might just say, well, there's nothing in between 72. It's just 72. And that's right. So this would be 144, and 144 divided by 2 is 72. So 72 is our third quartile. So right here, this is Q3, which is 72, or upper quartile. Now we've got all the information we need. So the upper quartile, or Q3, is 72. And then our lower quartile, or Q1, is 31 and a half. 31 and a half. And then you might say, well, where's Q2? Well, that's the median, but nobody really calls it that because it's got a fancy name, median. Quartile 2, but it's called the median. Now, so that's all the work we did. We found the median, we lined it up from least to greatest, found the median, and then we took the lower half. We took the lower half and found the median of that, which is 31 and a half. And then we took the upper half and found the median there, called the upper quartile, and that was 72. Next, time to build. Now, you need a number line. You want it as nice as possible. It doesn't have to be perfect, but let's draw our number line. All right, and we need it to include our minimum and our maximum. So it doesn't need to start at 4. Let's start at 0 inches, and it's got to go all the way past 108. So at least has to include 108. So let's go to 110. So let's try to make this as even as possible. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 100, and this will be 110. Okay. All right, so there's our number line. And now what I like to do is I like to find the points on the number line. Then I like to raise them up off the number line to create my box. So on the number line, I'm going to place dots at 4, which is the minimum. So that looks to be about 4. I'm going to place a dot at 108. All right, this is just setting it up. So I'm going to place a dot at where 108 would be, right about there. 108. I'm going to place a dot where 31.5 is, right about there. 31.5. Place a dot where 54 is, almost in the middle of 50 and 60. Place a dot where the upper quartile is, 72. 72 right there. And 108, already have that. All right, so now go ahead and bring your quartiles up. So bring this up, right about there. Bring this one up. You don't have to do those little dots there. Bring that one up. And you're going to make lines. This is going to be your box. So your quartiles become your box. Draw lines through your quartiles. And then draw a line through your median. All right, so that box represents the middle 50% of the data. All right, so there's our box. This is why it's called a box plot. So there's our box. And now we need the whiskers. So bring this up. Right there, that's 4. Bring that up there, that's 108. And then you connect the box to those ends with the whiskers. So if you want, you can even label this if you want. It's not a bad idea to label these, just so people know what these numbers are. 31.5. This was 54. And this is 72. Don't need to, but it does help. It does help. All right. So what this says is that 25% of the students jumped between 4 and 31.5 inches. It says that 25% of the class jumped between 31.5 and 54 inches. 25% of the class, 25% of this class jumped between 54 and 72 inches, and 25% of the class jumped more than 72 inches, but less than 100, and included 108. So between 72 and 108 inches. All right. This part here, this box, shows what is typical. This is a typical jump. So you would say that a typical jump is between 31.5 and 72 inches. If you were saying that, you know what, how far can students jump? You would say that according to this class, according to Mr. Marcus's third period class, students jump typically between 31.5 and 72 inches. And that's a pretty wide range, right? Because this data set is pretty spread out. All right, so that is how you create a box plot. Thanks for joining.